We'll put the chat in like a corner here.
Why do we only have 7 kids today? What the heck? Okay.
Oh, Jane's back. He can answer the questions. Yeah.
Yeah. Why isn't both barbers here?
Who is Aaron Larper hater?
Aaron, that's just Aaron. Like basically last class, like Gavin and like Evan. Do you know Evan Lua?
No, I don't know who Evan Lore is.
Bro, he was talking about knowing some like topology or something. He's like a seventh grader saying he knew topology. Okay,
Oh
whatever.
wow.
All right. I guess we're gonna get started.
Okay. So are we recording?
Yeah, yeah. That's very
Okay,
good.
okay. So this is kinematics review. Let me guess this is the first kinematic equation. Yeah, final velocity minus equals initial velocity plus acceleration times time. Uh, we've already gone over this. This is like kind of
Yeah, yeah,
self-explanatory
yeah.
because like acceleration is change in velocity over time, and if you multiply by time, it'll just give you like the velocity, like change in velocity. So if you add change in velocity plus initial velocity, it'll equal final velocity. If you can like imagine that, that's how it works. A car starts from rest and accelerates uniformly.
You don't
That
need to
can
do
be
problems. We did these problems. I just want to like because like I think they're having trouble like a lot of the kids, okay, I'll tell you what happened last time. A lot of the kids would have like calculation errors or they would have errors on like selecting the right equation. So just like you can like this
okay.
the
Okay.
initial slides can take like 5 minutes to do. Like it
Okay.
shouldn't
Okay.
be too deep.
Okay, so you'll use this equation, like you can see like the variables. We have final velocity, initial velocity, acceleration, and time. And if like you're reading a question, and you notice it gives you some of these like values, and you're looking for another one, you know you can use this equation, or like that's like how you can kind of tell what equation, kinetic equation to use. The second one, second kinetic equation. This one's for displacement. Yeah. So initial velocity times time. That's like how far you go, and then plus acceleration. Yeah, one half acceleration. I don't know how to explain this one actually, but this equation gives you displacement.
Yeah,
Yeah, and it works.
we like on the first two classes we kind of created it and showed why it kind of works, but like if you guys weren't there for those classes, just like trust this equation.
Yeah, this works. You have displacement, initial velocity, one half acceleration times time. Yeah, so you have acceleration here, and you need time. If you have zero acceleration, you can use this equation. At that point, it just becomes like the previous one,
Um,
kind of.
Lucas,
Actually, no.
Aaron said to
Hmm?
slow it down or talk slower.
Oh, okay. Sorry. Yeah, there's no problem. Oops. I skipped a page. So initial velocity times time is just displacement. So if you have zero acceleration, your displacement will just be that, and then like that's the acceleration term. That's how you can like imagine it. Okay. The third one, final velocity squared equals initial velocity squared plus two times acceleration times displacement. I don't know how they came up with this one, but it definitely works. So let's see. Again, if you have zero acceleration in this equation, okay, well, obviously, yeah, okay, so again, you have like a final and initial plus an acceleration component, which is like the change in your velocity. You would use this equation in like if you need a car like changing speed, like over like I've seen this equation used in like friction questions where you have like a
Hmm.
truck traveling a certain speed and how like it's asking how much force, like the amount of deceleration it needs to slow down to another speed over this period of time.
And
So that
then,
one's
mhm. And then I would highly recommend you guys like write these down because we're going to be doing a lot of problems with these. And also, Jethan will write in the chat like all four equations. Like we didn't cover one of them because that's just like distance is equal to initial distance plus velocity times time. But Jetson will write all four kinematic equations in chat. The reason why we're going a bit quick on this one and we're not explaining it too well is because we've went over this quite a bit in the classes before. So if you're confused on any of the stuff or Lucas is talking about, we would encourage you to go back and look at like class lecture one or two's videos where we talk about this very in depth.
Wait, yeah. Also, like, I only have one screen here, so if, like, there's a question in the chat. I might like miss it. So if you like remind me, that'd be
Jethin,
helpful.
yeah. You please feel free to either private message Jethin or or me if you guys have any questions because we'll be open to answering it.
Okay. Should we go over these problems here?
Um, yeah, let's actually we'll give you guys 215. Try to do as many of these problems as possible. Like even if you do one, that's fine. But just we want you to get like practice with the problems. I know some of you guys did done this problems like last class, but like repetition is always good. So,
Yeah, if you guys didn't have like the equations written down, we can probably write them down here. Colin, you want to write them down? It's
oh
kind of
yeah,
quick for me
yeah,
to write on.
yeah. And then you get to choose
I'll annotate the question. Very difficultly. Okay.
wait, why does it keep on undoing? Yeah. You see that?
Yeah, what the?
Is that happening with you as well?
No, mine are writing down like my
Oh,
annotations.
oh, is it because you're undoing mine, Lucas?
I'm not pressing the undo button, I don't think. Wait, is it working now?
Oh yeah, Jetin put a really good image in chat. Yeah. Feel free to look in chat for the
The equations.
my iPad doesn't want you guys to do the problem. Unfortunately, you have to. Okay, I can't do this. It keeps on getting erased. I don't know if it's
Or
someone.
I'll stop writing and see if
Okay.
it works now.
Oh, maybe it is that.
Wait, maybe only one person can write at a time.
Yeah. No, it just got erased again.
Oh, I didn't touch
Okay,
it.
wait.
I'm not writing anything.
Okay, there we go. Oh my Lord. Okay, I think you should just do it, Lucas. It keeps on erasing.
Uh, it's in the chat already. I feel like it's on in the chat.
Yeah, that's true. Yeah. Uh,
If you guys don't understand the subscripts, so if F like a subscript F means final, a subscript I means initial, and the like any variables you see for kinematics. So like V, like little I, like the subscript I means initial velocity.
I think you can just go ahead and start solving.
Okay, okay. Do you want to try writing stuff down again? Because
Oh
it's really hard
yeah,
for me to write on this track
sure.
pad.
Yeah, I'll go. Okay. So I'll just explain the problems then.
Okay,
Okay.
okay.
Okay. So basically for the first problem, the keyword is rest and acceleration and oh, acceleration and time, correct? We have t is equal to 5, a is equal to 2, and v initial, it starts, correct? So that means the initial is equal to 0, right? And why is my, okay, sorry guys, you're gonna have to bear with the, do you see this, Lucas?
Yeah, it's like erasing and like not. Yeah, I don't know what that's happening. What is the annotation permissions? Can
Okay,
anybody annotate?
equals 0. But once you have this, then you have you can just do 2 times 5 then, right, guys? Because you just have VI, which is equal to 0. So it's just 0 plus 2 times 5 is equal to 10. I think the first one's pretty self-explanatory. I don't think it takes too much thought process because it says it starts from rest, and for accelerating if you're accelerating at 2 meters per second squared for 5 seconds, you're just going from 2 to 4 to 6 to 8 to 10, correct? And yeah. Um, a car starts with a velocity of 4 meters per second and accelerates at 2 meters per second squared for 6 seconds. How far? Okay, this one's basically the same exact thing, but we're adding an extra second. And then we're also starting with a velocity. We're not starting from rest anymore. We're starting with a velocity of 4 meters per second, correct? So we just input four. Bro, here, Lucas, could I try sharing my screen and then you can
Okay,
keep sharing
okay,
my
yeah.
screen? Because this is like really annoying. Uh, Sorry, guys. Oh yeah, guys. I know we didn't have homework for class 8, but we'll give you guys homework for this week. I know some of you guys want the extra practice, so we'll make sure. And even if I know Lucas made some rotational kinematics homework, I think he can also make some tension and compression homework for like last week's class
Yeah,
if you
yeah.
guys want to practice that. But okay, let's see if this works better. P equals 4. Okay, I think this is working a lot better. A is equal to 2. So every time you're working with a problem, you always want to label whatever you have, right? So what Lucas usually does is he underlines. I like how he underlines usually. I just label it separately, but right. And here we're just trying to find how far this car travels, correct? So we just use x is equal to vt plus 1/2 at squared, correct? This is a kinematic equation that you guys should have written down or like looked at in Jet at the chat when Jetin posted it. But I think this is the one that'll be or this is the best one that should be used. And we see that you can input all of these in. T can be inputted here and here. 4 can be inputted here, and A can be inputted here. So when you input all the variables, you're confused. Is it okay? I think I should probably write this neater. Okay.
Wait, what are you confused about exactly? Like the like coming up with like the equation or like
Because
converting the question into numbers.
if
The
anyone's
equation,
confused with like coming up with the equation, you would have to look back at lecture 2 or 1 because that's where we created the actual thing. But so if you're confused about like the actual how I got the equation, you just have to trust it for now. You know what I
yeah,
mean?
just accept it as fact. Like in any physics class, like at least for AP physics, you get like a sheet with these equations. So just accept these equations as like true for now.
Hmm.
Because we derived them like a couple of classes back. But for now, we're just gonna focus on like utilizing these. So this equation is a fact. We're gonna assume that we're gonna use
There's
that for the class.
like if you look at the picture, all 4 equations Jetin put in the picture, yeah, you just like assume that it's a fact and like you just go along with it. And if you want to know why they're facts, you can look at lecture 2. I think it was lecture 2 that we did it in. But for right now, we're just gonna just input the variable or no numbers in the variable. So you get 4, except your okay, 4
Yeah.
times 6 plus 1/2, 2 times 6 squared. And then I'm just gonna go through this math like pretty fast. I don't want to 36 equals what, 60? So you get
Yeah.
60 meters. Do not forget your guys' units.
Oh yeah. If you miss units, it's usually like one free point gone.
Yeah.
And like this question will probably only be like worth 2 points. So you're only getting 50% of this question if you forget units. So
Yeah. Does this question two make sense? Do we need to go over any? Is anyone confused on any part of question two? No. If I'm not going to get any like things in chat, I'm just going to move on. Okay. A car moving at initial velocity of 20. So you get VI is equal to 20. Its acceleration is equal to 2. And we're trying to find its final velocity. So we're just going to put a question mark there for right now. And its distance is 100 meters, correct? We're given three out of these four. If you look back at Jethin's picture, we can use VF squared is equal to VI squared plus 2AX, correct? This is one of the
mhm.
equation. This is the other kinematic equation that is a fact, and you guys should probably know. But you just input these variables in, you get 20 squared plus 2 times 100 equals VF squared. So then you just get 400 plus 400 equals VF squared. You get what? 20 square root 2 equals VF. Or if you guys don't know how to like do the if you don't know how to like simplify a square root like that, you can just put in the calculator to find the exact decimals of square root 800. I don't want to like teach how to simplify square roots, but if you guys, it's totally fine if you guys don't know how to simplify a square root. You just use the calculator instead, you know.
Yeah. Something to note about this third question here. If you notice, this is the only question that doesn't give us time. And we also used an equation that didn't have time. And like the v velocity final squared equals v initial squared plus 2a delta x is called like the no time kinematic equation, I'm pretty sure. So if you're in like a question where they don't give you time and like you think you can't like find time given like with information, you're probably gonna be using the that equation we just used.
hmm Yeah, a lot
It's like
of
easy to help you narrow down.
it's like a pattern you see with a lot of the like the four kinematic equations. Each equation doesn't have a certain variable, right? So like if you look at the equation we just used, this one doesn't have time, right? This one doesn't have time. This one doesn't have the final velocity. If you look at what is it? The other one, one half, yeah, one half VI plus VF times T. This is another one that equals distance. This doesn't have acceleration in it. And like a lot of the equations, they don't have a certain variable because like you might not need that variable to solve and you won't be given it in the problem, you know. There's like a lot of different ways to solve for all the variables.
Oh, there's a question in chat. Shouldn't it be 2a delta x and not 2ax, or is it the same thing? So delta x is change in x. So if they're giving you like an initial position and like it's a final position, delta x is just final. Is it initial minus final?
It's final
Yeah,
minus
right.
initial.
Final
Final
minus
minus.
initial. Okay. Delta x is just displacement or like change in x. And like since in this question they don't give us like a set initial x, um, you can just assume it's at zero. Or like you can assume that like wherever the final distance is the displacement. So like delta x is just equal to x here because we weren't specified like an initial position, so we can just assume it's at like zero. If that answers the question. So like you would use delta x if you know an initial and final x value, but if they just give you like a distance of 100 meters, then we don't really know exactly how to do that. Like
Did
we
anyone?
can just
Yeah.
ignore the delta.
So like if it was like if we don't have the initial or final X, I mean, they'll always like so if this car or if this problem instead of said over a distance of 100 meters, let's say it said that this car started at the 20-meter mark of a track, right? And it crosses through the finish line, which is like the 100-meter mark, right? Let's say it's that, correct? And you're trying to find the final velocity of the 100-meter line. When it starts at the 20-meter line, you're just going to do 100 minus 20, and that is equal to the delta x, right? So it's just 80 meters. But in this case, it's just over a distance of 100 meters. So, like, it's just assuming that it starts from like 0 meters and then it goes 100 meters. So, like, the change in the position of the car is just 100 meters. Does that make sense? Yeah. Okay. Does anyone else have any questions on this? Um, Anyone else have questions on this, on any of these problems before we move on? No, no. Okay, if anyone's like, if anyone's just not gonna say like anything, I'm just gonna assume that you guys are good to go. Ooh, relative. I think we covered a lot of this. Like, again, it's like it's basically like if you're like it's just relative motions just basically depends on where you are, correct? So if I'm on a car, and if I'm in a car going 20 miles per hour, and then Bob is in this car, and Bob is going 30 miles per hour, and we're both on the highway, let's say, going below the speed limit because we're good people. Um, he's going
That's
10 meters. He's going Bob, Bob's my favorite human being. Okay. Relative to me, Bob is going 10 miles per hour, correct? If someone's standing outside, then Bob is going 30 miles per hour. But if I'm looking at Bob through the car, then he's going 10 miles per hour. That's just the basically the whole like um that's just basically the whole like idea of relative motion, correct? It just depends on how you're
Mhm.
viewing the frame of reference. I'm gonna skip through all the other relative motion slides we have. Yeah, this is okay. And then they like Bob a lot, it looks like.
Yeah.
Projectile motion. Ooh, okay. We're gonna be doing something fun with projectile motion we didn't do last time. Okay, so I want you guys to really focus on projectile motion. Lucas, you're gonna have to
Mhm.
explain this pretty well, Lucas, because it might be
Okay, okay,
complicated.
okay. Okay, so projectile motion, like if you guys think of like a cannonball, it travels in like a parabola, right? Like we know, like when you throw stuff, it travels in a curve down. And so this is like because of certain physics things, and that's what you learn when you do projectile motion. So okay. Uh, Say I push a ball sideways, like I'm on like a cliff, okay? And I push a ball sideways with only providing like a horizontal velocity. And we're ignoring air resistance. My horizontal component of velocity will stay the same the entire way down because there's no force like as the ball is going through the air that's stopping it horizontally. Only gravity is affecting on it. So it'll keep the same horizontal velocity, but the vertical velocity will change because of the acceleration of gravity. Initially, if I'm pushing it like straight out, it has an initial vertical velocity of 0, but gravity is accelerating it downwards, which is going to give it a vertical velocity.
hmm
So that's how
You
projectile motion is.
you always want to associate gravity only with vertical velocity, correct? Gravity will
Uh-huh.
never affect the horizontal velocity of an object.
Mhm.
Gravity
That
will
was
never like slow it down or speed it up.
yeah. That example of like gravity and like off the cliff and pushing it straight off happens when there's like no angle. Like I'm pushing it straight out at like
Yeah,
a
yeah,
flat degree. And let me think. Yeah, okay. So in that situation, there's no initial horizontal velocity, and all of the energy I put into this ball is put into vertical velocity. I'm no horizontal, like pushing out at the side. But like as soon
and
as we introduce angles into the yeah, what were you gonna say?
I was gonna like say like there's always like when I use this canon, right? Like what Lucas was saying there, like when we like introduce angles, there's always going to be two components of velocity, correct? Like Lucas said, there's going to be the vertical component and there's going to be the horizontal component. We can kind of split it up, right? And I know you guys don't know trigonometry yet, but like okay, for the purpose of this class, we're gonna associate cosine theta with horizontal and sine theta with vertical. Only for the purpose of this class, right? Once you get into trigonometry, you'll understand why we do that. But just for this class, when we're thinking of this and this, we're thinking of sine theta being vertical and cosine theta being horizontal. So when we're trying to see the velocity of a cannon, there's two components, right? There's v cosine theta and there's v sine theta, right? And basically, do you want to explain what this tells, Lucas?
Yeah, yeah, yeah. So trig is introduced when we add angles into the thing. There's a question in chat asking what is beta. I think you mean theta. Theta is the angle like we're launching at. So yeah, this like everything trig is not important in like any strictly horizontal movement. But as soon as we're shooting out an angle, then we need to use trig. So sine theta. Okay, so when we're considering the velocity of like our projectile, we split it into horizontal and vertical components. And so we have a like overall magnitude, which is like, say we're launching the ball out of the cannon at this angle at like 30 miles an hour, or 30 meters per second. So like I don't know, so like the V at an angle, like our overall velocity of the ball will be 30 meters per second. But like that, what makes up this velocity at an angle is a horizontal and vertical um component of the velocity, and to like split up the vertical and horizontal components of the velocity from this overall diagonal velocity, we need to use sine theta and cosine theta. And how we do that is we just take our overall velocity, and to find the horizontal component of it, we're going to multiply it by cosine, which is just like an operation, cosine of theta, which is the angle of the cannon that's getting shot out of.
Mhm.
And then for the vertical one, we're just going to do the overall magnitude v times sine, like a different operation on theta, which is the angle of the cannon, if that makes sense.
Like, do you guys have any questions on
Yeah.
just simply like you can almost just think of like taking the velocity and then splitting it into two different parts, right? Horizontal and then vertical. And then when you think of horizontal and vertical, just associate horizontal with cosine theta and vertical with sine theta, correct?
Mhm. Okay, v cosine theta. Cosine is an operation. It's not like three separate variables. It's gonna
Hmm.
output like a
Oh, okay,
number.
okay.
Like if we
Yeah,
know
yeah,
velocity, we know the theta value. Velocity times cosine of the theta value is just gonna give us a number, which is gonna
yeah,
be
yeah,
equal
yeah.
to our horizontal velocity.
Hmm.
Does that make sense to everyone?
As much sense as possible without knowing trig.
If there's any questions, you guys can feel free to ask. This is a
Yeah.
hard concept.
Okay, I'm assuming we're good to go because we're not seeing
Yeah.
any questions yet. Ooh. Oh,
What if
okay, we
Bob
see it.
jumps on a plane going 1,000? Oh wait, I don't know what happens if Bob jumps out of a plane going 1,000 kilometers per hour.
Wait, that has
But
nothing to
wait,
do with okay.
that seems a little unrelated. That is another question. Wait, cosine times theta is horizontal velocity. That's close. Cosine times theta times our velocity of the diagonal of the
Hmm.
ball shooting out of the cannon is equal to the ball's horizontal velocity, which is just a component of the overall velocity, which is big V, or like V.
Yeah, just Aaron, all you have to do is multiply cosine times theta with the velocity to get the horizontal velocity.
What about
Oh
secant
my
and
God.
cotangent?
Oh my God.
That's not
We don't,
related. I don't
yeah.
think you use that in physics very often.
Ooh,
Cosine
but
sine is like
it's good
mostly.
that you know that though. It's good that you know that.
Yeah.
Can I erase what's on the board right now? Or does anyone else have questions? I'll erase for right now. If you guys have any questions, Jethan is going to be more than willing to answer. Okay.
And velocity times sine times theta
Yeah.
equals vertical velocity. Correct. Yeah, yeah, yeah. That's correct. That's correct.
Ooh, okay. We just covered this, right? I don't need to go through this.
Yeah.
Oh, yeah. Another thing to know is with vertical motion, there's always going to be gravity acting downwards.
Hmm.
Unless, yeah. So just like keep
Gravity
in
will
mind
always,
that
yeah, yeah.
it'll always play a part. Yeah. Like, so just keep that in mind. Yeah. Gravity is 9.8. You guys can take, I think some of you guys already took a picture of this. I just added this because it's good to know, but just take a quick picture and then I'll move on.
Oh, and like, if you ever see like X and Y, X represents like on the
Mhm.
X-axis, it's horizontal, and Y is the vertical axis. So like VX is horizontal, and VY, that's like the reason between X and Y. You guys
Yeah.
don't know.
So if you ever see like Vx, this is just basically equal to V cosine theta, right?
Yes.
Because velocity of the horizontal, we covered this enough, I think. Are we good to go? Can we, I think we should move on. Okay. Aaron, okay. Yeah. Holy AI. Okay. Um, yeah, horizontal. Oh, you want to cover this, Lucas?
Yeah, okay, okay. So this is yeah, okay. So horizontal motion. So x is displacement. So x equals the horizontal component of velocity times time. This makes sense, right? Because we know like the distance you're gonna travel is just how fast you're traveling times the amount of time you traveled. So this is like the same thing. It's just in like a different form. So like horizontal distance is gonna be equal to vel- the horizontal component of velocity times the amount of time it's traveling. So
Oh,
it's pretty
yes.
simple. It's the
Hmm.
simpler part of it. And vertical motion gets more difficult because um, the speed of vertical component of the speed will be changing due to acceleration from gravity.
Also,
So it's
guys,
going to use
I would encourage if you guys like focus. Like I know like it's like I don't want to discourage chatting because I know it's what makes this class fun, but like also like lock it because like this is like the hard part. So if you guys get this, like it'll be great.
yeah. So vertical motion. This is like a parallel to our one of the kinematic equations, by the way. Oops. Yeah. So y displacement is equal to initial y velocity times time minus one half g, which stands for gravitational acceleration, which we know is 9.8 meters per second, times time squared. That's a parallel to the kinematic equation. But this is true because in vertical motion, we have an initial velocity, we have an initial vertical velocity, but we also have gravity accelerating the ball downward. So that initial velocity is going to change, which is why we need to include this acceleration component in the equation. That's why it's more complicated than the horizontal one. And yeah, the velocity,
You want to cover
the
them?
second one, yeah, the
Yeah.
vertical velocity question. It's the same thing because in horizontal motion, the velocity is never going to change, right? So like when you think about a ball traveling through the air, it's gonna be traveling the same speed like horizontally the entire time, but it's going to be accelerating downwards because of gravity. But like the horizontal velocity, the side to side velocity is never going to change. So there is no change in horizontal velocity, but there is a change in vertical velocity, which is why we have Vy is equal to V initial y minus GT. And that's just um your final y velocity is going to equal your initial y velocity minus the gravitational acceleration times time.
And you can see like where I added like so remember this is the initial kinematic equation we have, right? And if you look at this one, it's pretty similar, right? Except we substitute
There's
A
a
with negative G. Go
yeah.
on.
I was going to put in a negative part, but a negative g
Hmm.
because it's downwards acceleration, and like in physics, we have to have a frame of reference. So like normally we have up as positive and down as negative, and since gravity is accelerating downward, we put in a as negative g. So that's why.
And then, oh, sorry, I didn't mean to write VY. But if you look
So
at
negative
this
gravity
one,
since it's going down. Yes, that's correct. Yeah, negative gravity is plugged into this equation and it becomes exactly the same if you notice. Like this kinematic
mhm.
equation at the bottom of the screen, once putting negative g into it, it's exactly the same as what we have there.
And even with like this one, I wouldn't use Y. I would even say H instead of Y because like height, you could use
Yeah, yeah.
Y, but if you look at like the other kinematic equation we came up with, X is equal to VT plus one half AT squared. Okay, for the negative part, like it's like gravity, we're taking acceleration as a whole, correct? And we're when we think of acceleration, upwards is usually positive and downwards is negative, right? So like don't think of it like gravity as gravity.
It's
Like
it's not like we're not like it's not like a negative number. We're just using positive and negatives
mhm.
to determine like direction in this case. It's not like a yeah, it's just used to determine direction because it's a vector. A downward force,
That's
yeah. So
Not a force acceleration, but
if
yeah.
if we had like an upwards acceleration, we would call it positive, and then just a downward acceleration negative. These are
Mhm.
arbitrary values, just so we can like do calculations with them because they're in
Yeah,
opposite
yeah,
directions. So
yeah.
we're calling up positive and down negative. But you could change it around. You just have to change everything else around too. But like it's pretty normal to have downwards as a negative direction and upwards as a positive direction. That's why it's negative
You
g.
yeah. You could make it like Lucas said, you could make it downwards positive, but you would have to remember to make acceleration upwards negative then, and you would still get
Hmm.
the same answers. You would just have it in
Yeah.
your other things, right?
Hmm.
So if you look at the other kinematic equation here, you just look at how this is pretty similar again. We just had negative g instead of positive a, so this just gets minus one half gt squared, and then it's just instead of x, we just use y. Y is equal to the height, and then v sub y is just equal to the vertical velocity, which we have over here in these parts. Does this all make sense to you? This is a very complicated stuff. So if you guys will sit for probably let's just stay here for like 2 minutes, Lucas, so they get all
Okay.
this.
Yeah. Feel free
Because
to
like
ask me
the
questions.
yeah.
What about vertical distance? Vertical distance is the first equation in that line there. It says y, but you can think of it as like h height. So yeah, that what's that circled is the vertical distance equation.
Oh yeah, you guys should probably write all like every single equation I probably have down. You should not the kinematic equations, but horizontal motion. Yeah, y is height. Correct. Oh, sorry. My bad, Aaron. Okay. Um, you
It's
should
too
have the
blurry.
horizontal. What is blurry? Is my screen blurry?
It looks fine to me.
V is no, V is a
No,
velocity.
no, no. V stands for velocity. Too small. I can
Wait,
type it out to you.
yeah. And then you have to remember that V sub x is also equal to V cosine. Actually, do you want to keep it as V sub x for class instead of making
Sure,
it
sure.
cosine theta? Because I don't know if we
Yeah,
can keep it as V sub x, and then once we like forgot the whole thing, we can tell them like just re-input cosine theta and sine theta back in.
yeah.
I don't think that'll be too deep. Is
Is
distance the
distance the
same
same thing
thing?
as motion in this? Motion is kind of misleading here.
Mm.
Motion stands for like the
The
overall like
trajectory.
movements of this thing,
Yeah.
and the motion in vertical motion you can see it's split up into like the distance traveled and also the velocity component. So
Hmm.
motion is just like what we're calling this system of movement.
Yeah. It's like trajectory, like the path that it goes
Motion is not the same as like distance or velocity. Motion is like it has no meaning here. It's like the
on.
name of what we're calling this movement.
Yeah, yeah, yeah. Could we just say range and height instead?
Yeah, I guess. Yeah.
Think of it as like think of horizontal. I think what is like the correct term is actually range for the horizontal, and then height is like the vertical.
Does that make sense to everyone?
Can we move on? Oh, actually, Jethan, is there a way you can like write all this in chat because we'll be using probably all of the equations for the next part for the derivation of like the max height and everything. It is too small. What is vertical motion formula? Oh yeah, Jethan will write it all in chat. Don't worry. We'll give you guys another minute or so. Or sorry, Jethan, because we're just waiting on Jethan to write it, or Lucas, or anyone who has
Oh,
any
I can
of
type
them.
it out. I can't. I don't know a subscript on this, but
Do
I'll
you think
see
you
if I
can
know how to
find a good
subscripts.
picture?
Um, I typed out it technically, yeah. And in this one, y is equal to, I don't know subscript like the little y. So y is equal to vertical component of velocity times time minus zero point 0.5 gravity uh times time squared. That's the horizontal or like height formula. So is the formula of horizontal motion the same as the formula? Horizontal motion is not a thing. That's like it's not anything we're using. We're just calling it. That's just the name of what these two equations are called. Like horizontal motion, it's we just did that to match vertical motion. Like it's just the title of what we're calling these equations. It's not like
Yeah.
anything that's actual. Like we could call it like horizontal movement or like horizontal moving
Yeah.
things. Like motion is there's no meaning here. It's there's no formula of horizontal motion. It's just the what we're calling horizontal systems of movement. How we're these things are moving. Horizontal motion is made up. It's not made up. It just has no meaning here. Like that is purely just what we chose to name a title there. Like we
Yeah,
could like
yeah.
delete it. Like that's just to separate
We
horizontal and vertical.
could,
We could just
yeah,
put
we
like
could just
X or
say like
Y.
horizontal path or like horizontal
Yeah,
trajectory or
that's
like,
just the word we
um,
chose to put down. It has no meaning here. Is it still a thing though? Like motion is like the movement of things. So you could think of it as like horizontal movement. It's just a name. Like it's not. There's no concept behind it.
mhm. So like you could, I think you could also just say horizontal like distance because it's equal to distance. Like the equation's equal to distance. I think horizontal motion was a bad thing to name it. We
I
could
think we
just
put it
kept it
there
horizontal.
to match the
Yeah.
vertical motion below it. But like yeah,
But like if you like I think it's used because like when you plot it on a graph, it'll show you like a line. Like you're supposed to look at the path of a on the graph. It might be like you probably won't like that's deeper, but like yeah, just think of it as like the trajectory or path that the object takes.
so Jane sent an image, and it's pretty much what we have written down, except he has a horizontal velocity equation there. We didn't write that down because it's just Vx is equal to Vx initial, but normally there's no change, so we just ignored it. But yeah, Jane
Yeah.
pasted an image there of what should be there, like the
Yeah,
horizontal
yeah.
motion or vertical motion. That's what it's just what we call these equations.
Yeah, you can ignore the second equation. That's just fully useless.
Yeah. What is yo? So yo is just y
Initial. Sorry,
initial. It's a
zero.
zero. It's a zero. But like um we I or like a zero there, it's the same thing. Like
Hmm.
you'll see that notation all the time. So like yeah, so it says y is equal to vy zero. That just means height or is equal to vertical velocity initial times time.
Because you
Y
can't ignore the zero because it's not okay. I'll explain it here. It'll be better to explain here. What? It's y sorry. When we look at v zero, is that what it says or is it vy zero?
it's vy there, but it really doesn't matter like the order.
Yeah. It doesn't matter the order just because when you do v sub y zero, this is just saying the initial vertical velocity. Initial vertical velocity, right? Ooh, I spelled vertical wrong. Okay, whatever.
Yeah,
Velocity, right? If you had v zero or vx zero, this is just the in. Oh my God, sorry, I can't write. Um, Vx zero, you just have the initial um what horizontal velocity, right? Velocity. If I wrote Vxf, for example, this could be taken as the final vertical or sorry, final horizontal velocity, right? In physics, a lot of time
yes.
you'll have to like inference, you'll have to inference what the subscript means, even if you don't know.
Okay. So if you see a zero in the subscript, it means initial. And like you see an I, it also means initial. And if you see an
So
F, it
what?
means final.
Whenever you see the two things in a subscript, it doesn't ever mean like multiplication, right? You're just taking
No, no, no,
two
yeah.
things and you're just like adding them together. So if you see initial in a subscript and you see X in a subscript, you're thinking, oh, the initial horizontal velocity, correct?
Hmm.
And why isn't it X v sub X zero t? It's just like it's because the velocity can change over a certain period of time. So v, when you're thinking of vxt, you're just thinking of
We
the
didn't,
average velocity, total
no.
average velocity, right?
Um,
Am I wrong on that?
well, I don't know. I think he's asking about why in the horizontal displacement formula we're not using Vx sub x. We're not using V sub x
V
sub zero. But that's because there's no change in horizontal velocity. So there's no point in putting a zero or an
oh
F in there
yeah.
because it's just the
Oh
same
yeah,
value.
yeah,
We're just calling it V
yeah.
sub x. Like we don't not putting like an initial or final there because it's the same. There's no change in the velocity. But there is for vertical. There is for vertical because there is an acceleration component. Acceleration
Hmm.
is changing velocity. So if the velocity is changing, we need an initial and a final. I hope that
I
makes
guess
sense.
well, I guess that's where the second equation actually becomes useful because if you look, v sub x is equal to v sub x zero, right? So just writing the zero is just another variable you're adding, which
Yeah,
makes it
yeah.
messier.
The horizontal velocity Vx and Vx sub zero. That's funny.
Is there anything else?
You guys didn't write the zero on the slide, so I'm confused. Yeah, okay. So we took a shortcut there. Like I mean,
We did
technically
an
you
I.
could put a zero there, or like an I. You could put a zero and I there, but we just didn't feel the need to it because there is no final version of it. So if like there's a value and there's not a like a there's, it's not changing, we're not gonna put like a zero or an I there because that since that value's not changing, we can always just it's gonna be constant the entire time. So we're not gonna put like an X or an I. I'm sorry, we misled you. So it's just extra. If you put like a initial there, like it wouldn't be wrong, but you have an initial without a final. So like there's really no point in having an initial because if you just write the thing without like the I there, everyone's gonna know what you're talking about because there's no final value to like compare it with. It was just one value.
Hmm. It's also like a really good skill in physics to have, like to like make inferences and like on like subscripts, you know. So it's a good learning experience as well.
If you don't have a final, you don't have an initial. I mean, like you wouldn't have like waste time writing an I there if it's not value is never gonna change. Like I mean, you could if you want. You instead of writing Vx like zero, I'm like V sub zero sub X, you could just write V sub X because the zero is just assumed. Like it's never gonna be something else other than that. So it's like
In
one
the
less letter you have to write.
horizontal distance. If we're talking about horizontal distance, this is
Yeah,
only.
this only I'm glitching. Yeah, I don't have the greatest Wi-Fi here. Sorry.
Yeah, yeah.
Does that make sense to everyone?
And also like only like take what was like about the initial is equal to like the final in horizontal velocity, right? When you're looking at like problems, like the obviously like the final velocity can change versus like it can change from the initial velocity. Like if a truck is it ends up going 30 miles per hour but starts at 10 miles per hour. Obviously like the initial and final aren't the same, right? We're just talking about horizontal velocity in this case. So only like use it in this context. We'll also be doing projectile motion like in the or we'll also be like, ooh, wait, oh, wait, have I been on this slide, Lucas? Or did I just change this slide?
And the equations for max height and distance. No, you
Yeah.
haven't. Like a lot of the stuff was written on the correct slide.
Okay, okay,
Yeah,
okay.
I like you changed like pretty late into the thing.
Uh, okay, okay, okay. So now, this will be hard. Like we'll go through this with you, obviously, because we're gonna be introducing another equation, or it'll be a kinematic equation, but that will also be used in order to do this problem. Do you guys want to try doing it on your own, or do you guys just want us to go with it through it with you guys? You want to try doing it on your own? Okay. It'll be Okay, I'll let you guys try it on your own. Disclaimer, this is probably like I would say this is probably the hardest thing we'll we've created so far in class. So if you get this on your own, I'll be very impressed. We will be very impressed.
Yes.
Max height is like, oh, okay. Do we have to? Okay. So basically, max height and max distance, like the farthest an object can go in terms of the vertical and the horizontal component, right? Within like the row. Do you have a better way to explain this, Lucas?
Wait, what was the question?
I'm
Sorry, I wasn't paying attention.
He was asking like what do we mean by max height and what max distance?
Oh, okay. So max height. So like in a projectile motion arc, it's gonna travel like this, right? Can you guys like imagine that? Like, say we're shooting a cannon out of a cannon, it's gonna go like this, right? So max height is gonna be this very top, like the highest the cannonball will ever be, is what we're gonna call the max height value. And farthest on the x-axis the ball's ever gonna be, we're gonna call the range. Because like remember, the range is like how far your cannonball will land, if that makes sense. I think that's how I would imagine it. So yeah, our task is to find an equation to find this value of max distance and max height. Wait, this is hard. Have they ever done derivations before? Because like there's no values to this. There's just me working with variables.
We've done it with the kinematic equations and we've done it with Atwood machines where we've like derived the acceleration.
Okay.
So they
Oh,
have
okay,
a
okay.
bit of
Well, then this should be
practice with
fine
it.
then. Yeah.
I'll
Yeah.
write down all the equations needed to solve this problem in the right form while you guys solve. You guys solve, don't worry about what I'm doing on the screen.
Right. Yeah. This is gonna take some pretty conceptual thinking here. You have to think about like the conditions of the ball at these points in time.
Sorry guys. Yeah.
So we need the equations, solve the equations. Yeah, you're gonna need the kinematic equations to solve this.
Ooh, should I like write it in terms of like should I give them the general formula or should I just write it in terms of like how it should be on the
You already
I
started
don't
writing it like in
yeah,
terms of the.
I'll just write it in terms of the thing. Uh don't worry if you guys don't get these things because we'll explain it while you guys do it later. Am I missing anything?
Yeah, I got a background. Is it backwards? No.
Yeah, let me see.
Is it
Ooh,
reversed?
wait, no, wait, mine is. Wait, what
It
the
says
heck? I didn't even.
no, no, no. On your screen it looks normal for me, but on is
Oh,
mine?
yours is normal for me. Yeah, yeah.
Okay, well, I guess it's normal. But these
Oh,
are normal for me.
interesting. Interesting. I'm not missing anything with the other one, right, Lucas? Like the top, like this, the one I boxed. Am I missing anything with that or no?
Wait. What is the
Oh,
question?
Naramol has an answer. Ooh, someone got an answer? Wait, DM it. Don't, if you have an answer, don't.
It's close.
Wait. I don't know. I won't be giving answers away
Oh yeah,
because because I know people actually want to like solve it and like so. If you have an answer, just put it in chat.
we got them. What were you asking about the?
Like I'm not missing anything with the box, right? This is all that needs to be used, correct? To solve for both.
You need no wait. Uh, okay. I think you technically need the change in velocity one, like just like the very basic like final velocity is equal to initial velocity plus acceleration times time. I don't know if you want to write that down though, because that's kind of self-explanatory, but you do need that.
You do.
Yeah,
Final velocity is equal to initial velocity plus
plus
acceleration.
acceleration times time. I don't know if we need to write that down though, because that's like super simple.
Oh, we do? Really?
Yeah. Um, I think so, right? Because how else are you gonna find time in the time in the air?
With this one, no.
Which one?
The one I underlined. I think there's different ways to do this.
Oh, wait, let me think.
Because when it hits the ground, it'll be zero, correct? This you can just set the y to zero.
Yeah, but then yeah, I actually yeah.
What is this? Oh, that's my iPad, by the way. Ooh, sorry guys. Okay. Right, that's like really hard. Why does he keep on doing that? Okay. Yeah, I'll go through this problem very slowly. Oh man, will we not have time for rotational kinematics again? Oh my God. That's fine. Oh my God. That has to be like the best cannon you've ever seen in your life, Lucas.
It is pretty good.
Okay, the trajectory is a bit wonky. I know Miranda wanted to solve it. Are you still um going through it, Miranda, or can we help? She's locked in, guys.
For sure.
God. Why can't you guys be like her? There we go. Oh my God. Okay. Miranda. She's still solving. Oh my God. Okay. I'm pretty proud of this.
It is pretty impressive.
Um, what? We only have how much workspace do we have? Oh, it's an all workspace now.
Are we doing a bucket today? I don't know if we'll have time today.
Uh, yeah, because we have to cover rotational kinematics as well.
You explain the last equation for me? Which is the last equation? Which one? The one at the bottom of the general equations. Okay. That's just the displacement formula. So it's one of the kinematic equations. Displacement or the x, since we're assuming the ball is starting at zero here. X is equal to velocity times time plus one half accelerate times acceleration times time squared. So if we have initial velocity and acceleration, we can find displacement or x. That's what the equation's for. I hope that makes sense.
I think time. Do I'm sorry, Miranda, but I think we have to get going with this.
Oh, is that what I sound like? Huh. It's because time's in the equation, and you also need to, I'll say multiply from now on. I won't say times.
I got that one, Aaron. That was funny. Oh my God. Miranda's locked for the. Oh my God. Wait. Oh my God. I think I got. Oh, I only got range from Miranda. But that's okay. That's okay. That's okay. Okay,
Restart.
let's go through it. Let's go through it. Okay.
Oh, wait, you changed. Okay.
Um, basically, so whenever we're like stuck, right? We're gonna draw the picture. I already drew it here for time's sake, but we're gonna solve for the max height first because max height to solve for the max height is always easier first. And basically to figure out the max height of the like of an object, right? Let's say we take this cannonball that I made, right? To figure out the max height that the cannonball travels, it's gonna be up here, correct? And at this max height, the velocity will be zero, right? Because when we're talking about max height, um that's the farthest it goes before it starts dropping down because of gravity, right? And basically that's when velocity is equal to zero. Does everyone get that?
The
So in
vertical
order to,
velocity.
yeah, the vertical velocity is equal
So
to
like
zero.
if you when you throw like a ball up, there's like a point at the very top of the ball, the max height, where it's like kind of standing in the air, right? Where it's like it's like super slow going up and like it pauses just for a second in the air. That point is the max height there. And this is the same thing, except there's also a vertical component, no, a horizontal component, which is pushing the ball sideways. So it's like the exact same thing, but like the ball's also going sideways at the same time. So that's how
Mhm.
you can think of it.
But like in terms of vertical motion, it's like stuck vertically.
Hmm. Yeah. So there's zero vertical
Mhm.
velocity.
Does that make sense to everyone? Like, because that's like the important, like that's a very important step in solving. Yeah, but in that one,
It
like in
is
that very
we
short
we only need
time,
1 point. We only need 1 point
yeah,
in
yeah.
time.
Because if you look, like, there's no, like, yeah.
Yeah, because the max height happens at one instance in time, and that's what we're solving for.
Does everyone get this step?
Stop saying time. Sorry.
Sorry. Does everyone, this is like important for the max height. Because if you understand this, you can just like, it's so much easier. Yes, no, maybe so. Yes. Come on, come on. We're running out of time, guys. I need a yes. I need a yes. Or okay. You're not. I give up. I'm just assuming you guys understand it. But the next part is if we set this if we set this y is equal to, sorry, and then if we input this back into this equation, like because this is an kinematic equation we can use. Um oh, I have to explain this as well, right? If you take this one, right, and we just substitute it, so it's just a vertical velocity, and then we just substitute a for, remember, we can substitute positive a for negative g because negative g, it's going downwards. And then instead of taking we're just substituting x with h because h is talking about height, and it's like almost the same thing. We're just like interchanging the definitions almost a little, correct? And then
I don't understand that.
once we do that, we can substitute the zero, and zero squared is just equal to zero. So then you get zero is equal to the initial, sorry, initial oh my God, my pencil only. Okay.
Vertical initial velocity. Wait, max height is v sub y.
UN.
Un sub. What is un?
Okay. Um,
Okay,
so
this
then
isn't
we
like even
have,
work. Just think of height as h. Max height is h. There's no velocity. Um,
oh,
of
unsub.
unsub. No, wait, no. That's not it. That's not it. Max height is just h. There shouldn't be no velocity unless like when the equation
Mhm.
equating it to it.
So again,
But
we're trying to
that's not
solve for
correct.
this. Trying to solve for this max height, correct? Because once
Hmm.
the final velocity is equal to zero, the max height. So we're trying to get this height alone. So we just get 2gh equals vyi squared. So then you get um vyi squared. I'm running out of space. No.
Vyi squared.
Okay,
Uh,
you get over 2g, correct?
yeah, over 2g. Does that make sense to everyone? It's here it's just manipulating equations.
Yeah. And then this is just equal to the max height. Does this make sense
So
to you?
yeah, so if we solve for the initial like at the moment the ball is shot out of the cannon, if we solve for the vertical velocity of that, we find that value, we square it and divide it by 2 times 9.8. That'll give us the max height of the ball it's going to travel to.
Hmm. And then I'm just gonna move on to range. Okay, so then for the range, the important part of range is realizing that there's like the max range is when the cannonball hits the ground again. So when this y is equal to zero, correct? And we're using, I'll tell you why we're using this equation later. But when this y equals 0, we just get vyt minus 1/2 gt squared, correct? And we're using this equation because we're trying to substitute time to solve for x, right? So if we have
Yeah.
vxt, ooh, go on, Lucas.
Okay, so we're looking for time here because we know there's no change in what do you call it? A vertical velocity. No, horizontal velocity, sorry. There's no change in horizontal velocity because there's no horizontal acceleration. So once we find the time the ball is in the air and we multiply that by the initial velocity, the initial horizontal velocity of the ball, that'll give us the range. So like all that we have to do is find the time, if that makes sense. Because we know the velocity, we know the speed that the ball is traveling at horizontally, and we want to know how long that ball is traveling at this horizontal speed to find how far it goes. And that how long it's traveling at this speed is determined by the how long it's in the air, right? Because we're assuming as soon as it hits the ground,
Hmm.
stops moving. So
Yeah,
that's what we're
we're not.
solving for here.
Hmm. So, and then to solve for t, we just get 1/2 gt squared equals vyt. You can cancel out the t to get what? 1/2 gt equals vy, and then you just get 2 vy over g is equal to t, correct? So then once we get t,
Yeah, I think.
we can just put this back up into here. So then you just get x is equal to vx times or sorry, times, yeah, uh, I shouldn't do it. Okay. Times
Times
vy
2v.
times 2 over g. I should have put it like this actually. E, ooh, I already have the equals x. Never mind. Right. This is the equation for the max distance. And then you can like, I know um, Miranda just did it a bit differently, but yeah, you can substitute cosine theta and sine, like v sine theta and v cosine theta. And so like you see how I wrote the vertical velocity. Remember we talked about how the vertical velocity is equal to v sine theta, and we talked about how the horizontal velocity is equal to v cosine theta. You can just substitute that here, and you can substitute this for v this. So then you end up getting v squared, 2v squared sine theta cosine theta, and that's like a trig identity. So you get sine 2 theta over g. But that's a lot deeper. I don't want to have to go into all that. Does this make sense to you guys though? We're just gonna keep it as x equals the horizontal velocity times, or x equals 2 times the horizontal velocity times the vertical velocity over gravity. That's what we're keeping it as.
Yeah, and if in the future you'll have to know that vertical velocity and horizontal velocity is equal to those trig identities
Mhm.
we explained earlier, which is so you would find these vertical and horizontal velocities from the overall velocity and the angle.
Oh, did you get lost in the? Okay, so let's just split this up, right? Oh my God, I should do this neater. But this area is talking about the max height, and then and then I'll just recap. And then to solve for the max distance, you solve for t, and then when you solve for t, I'll just okay. I trust that you guys like know how to solve for variables, because because then if I don't have to explain like how to solve for the variables, it makes my space a lot neater. But basically, you can just convert this into 2v sub y over g is equal to t. This is what this equals. And then you substitute this up here, and then you just multiply it to this. And again, this all stems from the fact that the maximum distance that can be obtained is when y is equal to zero, when the height is equal to zero, correct? And
That
it's the
makes
same
sense.
thing
Like
that's the same thing for the height. When the maximum height that can be obtained is when the final velocity of the object, the final vertical velocity of the object is equal to zero.
does that make sense to everyone? If you have any questions, you can ask them. Are we going to play a game?
Do
I don't
you
know if we have
want
time today.
to
Do we
do
have
you
one
want to
like
go
lined
through
up?
rotational kinematics right now? Because I
I feel
feel
like this
like
is
this is
enough
a
for today.
lot.
Yeah, I
Yeah,
feel like this is enough
we
today. Do,
like
do we have a book
tortured
lined up?
these children. Do you think you could do this? Do you think you could find a book here real quick?
I can look. Let me look.
Okay, you can sleep after class is over. How about that? That's a good deal.
What should the topic be? Just like kinematics again? I'm not.
Okay, it's okay. That's the if you guys understand the process, that's like the main thing. And then like just getting the answer, like you can just like memorize, right? I'll write uh let me see if I can find a good picture.
Autumn, what should the book be on?
Uh
Kinematics.
Projectile motion.
Okay, yeah, yeah.
I
I'll look
think
for
so.
it. Oh man, this is difficult.
Okay, I'll keep in mind for next time to like do the step-by-step process that I usually do. Ooh. Uh, okay, the problem with okay, you know what? I'm gonna use this image, Aaron, but
Do you guys care what we play? Gold Quest Frenzy. Guys want to do Fish Frenzy? Crypto Hack? Okay.
oh my God, Aaron. Okay, so like the way we taught it, like when you look at pictures or like when you look at it online, you won't see it necessarily, but like when you look at this, just think of when if you see V and then sine theta, if you ever see that, just think of V sub Y. And then if you see V cosine theta, just substitute that with V sub X. And then if you see V squared sine squared theta, just do V sub Y squared.
Yeah. We
Here,
didn't.
actually, okay, can I
This
delete
is
all this?
technically. Yeah, yeah, sure. Oh, yeah. I think so. At least I feel like everyone has it. Wait. Okay. So what Gautam trying to explain is that we didn't like fully simplify our final formula equation. We didn't. We skipped the step in turning like V sub y, and V sub x back into like just the overall in terms of the overall velocity and theta, because that involves like the sine and cosine trig
Hmm.
identities, which is kind of confusing.
Yeah, and I didn't want you guys
So
to
we skip that step. But in like any theta and cosine theta, because that's what's actually used. Because like in any real like question, you're gonna have to find like the horizontal and vertical components of the velocity from the overall magnitude of the velocity and an angle. So that's why in all the like online formulas, you're gonna see like sine theta and cosine theta. Oh, we have the same answer, but we just didn't simplify it to that point. We just have it shortened, which Gotham's gonna write right here, I think. Also, send the book in chat.
Mm. And then actually learning what t is also equal to is pretty useful. Tv over t, correct? Yeah.
T is time the ball is in the
Oh.
air.
Oh, do you guys all right. Let me stop sharing. So oh wait, no, I need to share the show the equations. Uh, which one is it? Oh, it's right here. Never mind. Does everyone get the thing, or should I reshare my screen and do it? Lucas shared it 364. All right, 364918.
I share my screen. You guys need to see the bucket.
36. Oh, I sorry. 364918. 364918. Yeah.
There's 6 people in. Is that everyone?
Share
Oh,
your
five
screen,
people now.
Lucas. Share your screen.
Okay. Wait, it's like small. I have a split screen. Let me see if I can.
Hmm.
Is it big now? I'm just gonna start it. You guys can just add late joining this one.
I'll turn recording off now.